Hello, everybody, and welcome back once again to Saturday Morning Coding, episode 18. You might remember uh, from the last Saturday, we are making some sort of Pong style game with with STUMGE, which is um, web micro framework for games that I coded that is available on GitHub. And this is where we were so far. So we had a ball that rebounds and two paddles that cannot move or do anything. And yeah, so I think that the next step, because my plan is to make this game so you play against the computer, and we are gonna only make the interactive for the user, the paddle on the right side, and the other one will move automatically according to some like algorithm or something that we can think of. Yeah, and yeah, if you have any question or something, you can do it. You can write it in the chat or and yeah, we can continue. So right now, what we are gonna do is to make the paddle on the right interactive. So for that, this is the graphics class, but we are gonna move this to its own file. So far we have this is the ball that updates. So for the sake of keeping things in order, we can just create a like player paddle file. So there will be two paddles. One will be the player paddle, and the other one will be the artificial intelligence or the computer paddle, and it's good that we can separate them. So right paddle. This is the graphics, and in the same way that we are creating it. This is the other. This is a different game. Yeah, this is it. So we are loading as well. Here the player paddle.js. Oops. So it will be a global object, so we can access it as well from here. And now we can remove the right paddle because we are going to move it to its own file and its own class for the sake of organization. So in the player paddle we do this. This becomes a global object, so we can use it here. As you can see, I'm a little bit inconsistent with the usage of semicolons at the end of the lines, but that's something I'm working on. I'm not sure whether I prefer to use semicolons or not, but yeah, I'm still a little bit inconsistent with that, unfortunately. So So now we have the graphics, and I'm gonna call this, instead of right paddle, player paddle graphics. And now we should have the same exactly the same functionality here. So yeah, nothing has really changed. If you see the console, there's no errors or anything here, so it seems that we are doing okay still. And yeah, so we are left paddle, player paddle. Okay, so the player paddle, first thing that we need to do is that it responds to the up and down keys. We can close this, close the balls. Yeah, this is the whole engine, so the uncompressed version. So we now call the ball update. When update sprite should be player paddle update. There's total in the engine. There's absolutely total flexibility to do this, to organize this the way you want. So it's nothing is really like enforced. But I have found that separating each object, each game object into its own file helps as well to organize the logic, and yeah, it helps to keep things organized. So now we need to do like we did for the ball. We are gonna have we are gonna add functions to this. So because we don't want to create a new class, do we want ball to still be sprite, but each sprite has its own update, can have its own extra functions. So if we do this update, and then here we say, you know, here we can access. Yeah, we need to access the. Yeah. Yeah, I'm just thinking that this one doesn't need it yet, but in the player paddle you need to pass the engine, because we need to check the state of the keyboard. So you need to pass the engine here, which we can do where we can do where we update all the sprites at the engine level. So so now we have some x and y. So this okay. So let's see. How was this method? K down or K up? No. K press or K pressed. So once per frame, we are gonna use this, so you can keep the key pressed to keep on acting, and you don't need to do like, you can keep the key pressed and it works, and not only just one press. So so now in the engine we can do if engine dot k pressed, and here we need to pass a key code. So this is gonna be up. If the up key is pressed, STUMGE k up, then we do things. Again, if the key down is pressed, then we do things. That's why we need to have the engine instance here. We can annotate it. So if we annotate it, the IDE knows the IDE knows what parameter is that, and it's also good that we param engine, which is of class it's of class STUMGE. How do you do this? STUMGE. This is of class STUMGE, and the explanation is that executes updates the state of the player paddle once per frame, and that's it, and receives an STUMGE. So now the IDE knows that this is a STUMGE, so it's an object of class STUMGE. So now we have access to all the cleverness of the IDE. Yeah, so we don't need to check all the time. Anyway, that helps a lot reduce errors. So we say we can have a variable here, player paddle dot speed equals, let's say 1. This is gonna be pretty slow, but so you can do now, if it's up, you can do if this dot x is bigger than 0. Remember that in the sprite the 0, 0 is the top left corner, so if this dot if this dot y is bigger than 0, then this dot y minus equals this dot speed. So we only move up if we can actually move up. Well, actually, we should check that minus the speed is bigger than 0. So we should do minus this dot speed equals 0 is bigger or equal than 0. Then we can move. But we need to check. Yeah, because this can still be minus something depending on the speed. We can do this. It's easier maybe. If this y is smaller than 0, then it's 0. What is the problem here? Oops. If this dot y is smaller than 0, then we put it to 0. And same for up, same for down, except that now we are moving down in the x-axis. So this dot y plus equal this dot speed equals STUMGE height, but it's on the top corner, so STUMGE height minus this dot height, this dot get height, then this equals this STUMGE height. We can add a comment here, movement up and movement down. And now if we reload here, oops, now it disappeared. No? Obviously there's some sort of bug, because when we press up it works, but when we press down it disappears. So this dot I plus equals speed minus this dot get height. If this dot is bigger, now we are moving properly. And we can go up and down freely. It's very slow, as you can see. So we need to, if we change this, now this speed parameter can change to anything that we want. So if we change it to 2, we will be twice as fast. Still works. Once we can start playtesting the game, we need to tweak this parameter so the game is actually fun and not impossible. But now we have an interactive paddle on the right, which is gonna be the human player, and it goes with the keys up and down in the keyboard. And it also works when you leave it pressed. I'm thinking, should we make the paddles a little bit bigger for this surface? This look like really small. We can do this player dot scale. Did we have the scale? Or we didn't have the scale. Well, we will need to change the sprite itself. We can think about that later. I should add as well to the engine sprite scale, also for animations. Sometimes it's useful. So because now we have horizontal rotation, horizontal flip, vertical flip, and that's it. We don't have a scale up or a scale down the size of the sprite. Yeah. Yeah. Now we are gonna check when it collides with the when it collides with the paddle, and that's easy. We need to either what is gonna change state, the ball. So yeah, we need to pass to the ball, to the and this is, we can comment here movement, and here we can do collisions, which are part of the update function that need to be checked every frame. Yeah, now we are gonna check the collisions. So we need to check when the paddle has when the paddle collides with the ball. And for that, we need to decide, is the ball that collides with the paddle or the paddle that collides with the ball, because the ball will change the state, the direction, and so on. We should it should be the ball who collides with the paddle. So we have to pass the engine. Yeah, it's as well as STUMGE. The IDE already knows, but we can just even tell further. Yeah, and of course we could, I don't see it necessary, but we could store as we do with the ball for a more smooth movement. We could store this, we could create float variables so it doesn't jump, because if we set this to, let's say 20, which is obviously way too fast, it looks like it jumps, but I don't see it necessary, and this is way too fast to be controllable. So so yeah, I think that 2 or something like that, it should be fine. So I don't see the reason to have like a real X and real Y here. We are not normalizing or anything, it's only vertical movement, and we don't need this. We don't need to keep an extra float variable in order to keep the result. I'm thinking, how can we do this properly? And we pass here the engine. Maybe we can have the this the elements ball, ply, and the paddles as part of the engine. That would be, but because otherwise here we need to pass both paddles here to the update function. So we need to refactor this. So yeah, let engine, and here in the engine we have engine dot sprites equals this, and we can do it can be a dictionary, I mean an object, so it can be like left paddle player paddle and ball. So now the sprites are all here. So if I do engine dot left paddle engine dot sprites dot left paddle engine dot sprites dot player paddle engine dot sprites dot ball, and we do engine well, we can do actually this here, not engine. Why are we doing engine? This, we do this dot sprites dot ball dot update, this dot sprites dot player paddle dot update with engine with this, and this receives this as well, and then and this is the update, and in the update we really do this. Yeah, this is an augmentation that we are doing of the engine class, of the engine object. And now by doing this, we can just say in the ball, we can just say if engine dot sprites if this dot collides with engine dot sprites dot player paddle, then we hit. Of course, it's hitting continuously because because we don't rebound, so the ball follows the trajectory, so it's hitting the object for many frames in a row. So but yeah, now we are detecting hits. So without only passing the engine here, and here we can do yeah, we need to do this, so we can do this ball dot rebound, for example, was a function. Here we don't need parameters, and then we do this. let's see. This dot rebound. So if collides with a paddle, it rebounds. So to rebound, we don't really need to do this. So rebounding means this direction, this dot direction dot x is inverted, and this dot direction dot y is inverted. Only we are on the right side, so both directions are inverted, I guess. We can't think about this. Yeah, because here we are doing rebounding, but against the wall only. So let's see. So if it comes from this side, you just do, and that means that yeah, we need to see in which direction does it come, because this is not gonna work, but we can test it. This is not gonna work. It's gonna rebound very artificially, or not. Yeah, that's not a good rebound. So we need to check if which is the current direction, and that's not a good rebound either. Oops, we need to check that. It gets stuck. It can get stuck, so we need to check that. So in this direction, it rebounds properly when it comes in positive. But when it comes in negative, yeah. Okay, so we need to check if the direction is, I'm gonna write that to do here, check incoming direction and change current direction accordingly. Because this only works for when both are positive. So if this dot direction dot x is bigger than 0, and this yeah, we can do this. We can do just that. So if this direction that x equals, this comes here, and this comes here, but in else you only change the x, so and here you only change the y. I'm not sure. I didn't think this through, so it's probably also flawed. Let's see. Okay, now it comes. Now when it's both negative, it kind of works. That doesn't work one more time. I need to think this through. Let's take the iPad out. This makes no sense whatsoever. I'm let's think this through. Let's think this through. So yeah, let's change to the iPad. So yeah, how we need to think this through. So the thing is, how is this gonna? So this is the 0, 0. So x is positive in that direction and y in that direction. So we have 4 options. So x bigger than 0, y bigger than 0. That means that it's coming in this diagonal. And we want it to rebound in this diagonal. So that means that x needs to be reverted, but not y, because y keeps on being down. So we have this case now, x, y, positive, negative, positive, negative. So when both are positive, x changes. I'm gonna note here the ones that change. So x changes. If they are, if x is positive, but y is negative, that means that the ball comes like this. And we are talking about the direction, and we want the ball to go like this. So this means that the x needs to change, but y doesn't, because we still want it to go up. So if in this case, if x is positive and y is negative, then in here we only want to change x as well. The next case would be oops. The next case would be when x is less than 0. That means that the ball is coming in this direction, which is just not possible according to how we have designed the game. So if x is equals to 0, I mean if x is less than 0, that's just not possible. So this is we don't need to contemplate that case at all. Because X always comes in that direction. So yeah, basically rotating, rebounding from the paddle, it's only, let's switch again to the code. Rebounding is only yeah, multiplying changing the direction on the y-axis. So this dot direction dot y times equals -1, and let's see how this works. What? What is this doing? Yeah, let's print the direction every time that we update and see what is going on. I know what is going on. We need to do the collisions before the movement. That's something that we need to do for sure first. And yeah. Okay. It's still kind of am I doing it? Oh, yeah, because let's see. Now the ball obviously will disappear. Yeah, with the sides it still needs to collide, but not with the not with the with the top and back needs to collide. So it needs to collide with X, with Y, but not with X. I don't know what is going on here. We are making some mistake in there. This should be as well part of the collision of the rebound function. So need to move this. So this dot rebound needs to be always executing, and yeah, that's gonna be our collision detection function. We call it rebound, but we could call it somewhere something else. It's also tricky that that okay, let's make the ball slower. So we can check really this, because now this is something. When it's colliding, that's also something. Yeah, it's a stain. We may need to add this check. Ball dot colliding equals true. No, it was false. But yeah, how can we fix this? Okay, so I set it here, and this dot colliding equals, and not this dot colliding, then this colliding, this colliding equals true, and else this dot colliding equals false. If not this dot colliding equals false. Let's see how this goes. I kind of not really like it, but x is 1 minus 1. What? So now both are 1. Now rebounds. Yeah, minus 1. The problem is that it collides twice. For fuck's sake. I'm changing Y. I didn't do this right. I didn't back to the whiteboard. I don't know. Okay. I don't know now why I cannot see the. Okay, now. Oops, now it's way too big. Okay. Back here. I definitely need to change the X direction and in the because and I'm changing the Y. As you can see in this here, I'm changing the Y, so I don't know what the probably we don't need the freaking colliding stuff. Let's see if this works, and I need to change the I said I need to change the X and I ended up changing the Y. Yeah. Yeah, that's the thing with the new version of the Y thing. Doesn't collide with this wall anymore. Yeah, I was changing the wrong thing, and I thought it through, and let's make it so it rebounds on the for testing purposes. It rebounds on the uh, on the player. If this real x is less than 0, this direction that x. So now it should rebound on the right side, but not on the left side. If I let it go from here, it just goes. Yeah. Now we are playing like solitaire ping pong or something. Yeah, that means this is that collision I don't really like, when it just touches the corner. I was trying to, yeah, I can. Yeah, also something that I don't like is that you can rebound from the back. So yeah, we need to take that into account, but so far, yeah, I think that we have progressed a little bit in the game. Yeah, that's the thing. That yeah, we need to check that the collision is not from the back. So yeah, but we have made the paddle collide successfully with the ball, and as you can see, the code is fairly easy to follow. I will put, when this game is finished, I will just put it up to GitHub, and you can improve it or do whatever you want with it. So, but yeah, I think we are gonna leave it like this for now, and we can just yeah, we can just end it up here. Thank you for coming, and see you next Saturday. These videos will all be on YouTube, so starting with episode 17. Unfortunately, the others I cannot put anymore because I don't have the original source. But starting with episode 17, so all the Pong videos will be on YouTube. Thank you, and see you next week.